Now I am. Oh, darn it. Okay, now the last one. Now the last one's going to involve completing the square. What we got is a quadratic. All right, so we want to go ahead and do the same thing. All right, and what we want to do is we want to get this to be a binomial squared, right? So we're basically going to treat this as if we were solving this problem, but we're going to keep the y variable there. All right, so subtract 11. Now, some of y'all like to do your little factoring out thing. I'm not going to do that. I'm going to divide by 3. Okay, and so this is what we want to create the binomial square. So, you know, we want to create this situation, right? Depending on how you guys see this, you know, we want to split this into 2. So that's why it's 1. And then this would make that, so this means we're going to add 1, or the way I've been doing it after that student who had Asperger's. What do we need to add to both sides? We need to add 1. All right, so then that's what we'll do. So we'll add 1 here and 1 here. All right, I'm going to pause for a second. Okay, so now this is what we got. All right, let me double check, make sure I didn't do anything stupid. I don't believe I did. Yeah, we're good. Now maybe you want to make this 3 over 3. All right, so basically we're going to now take the square root and then add 1. So we'll do this. Don't forget plus or minus. And then we add 1. Okay, and then finally, we now have the inverse. So the inverse, and I guess I'll put this here, of the original function is 1 plus or minus this. Okay, now remember what this is. This right here is a parabola. All right, and so crosses the x-axis someplace, it's open up, so we got something like that. All right, so there's no problem with the x here, because we're going to go infinitely in both directions here. So the domain of the original function is all real numbers, but the domain of the inverse, we're going to have an issue. Why is that? Because that right there cannot be negative. Notice this is related to the value at the vertex. So we can't have a value of the vertex less than this. So the value has to be greater than the value of y at the vertex. That's what this really is. This is the vertex. Because remember, we're switching the x and the y. So now the y is going into the square root. All right, so basically, this has got to be greater than or equal to 0. All right, so subtract 1, multiply by 3, add 11. Okay, and that basically is the vertex. So that would mean that this is 8. And whatever the axis of symmetry is, that would be negative b over 2a, right? Negative b over 2a. So the opposite of negative 6 over 3. right? The opposite of -6 over 2 times 3, right? Negative b over 2a. So that means this point right here is 1, 8. Is that okay? I don't know. I know it's a little restricted, but if you don't want to say anything, just you can text me something that you're not quite sure of. All right, I'll wait about a minute. Sorry about that, Tori. I thought I had admitted you earlier. All right, so I did start recording this after the third problem, so I'll share the recording with everybody a little later. All right, so we good? We'll check participants. Okay, looks like we're good. And so I'm gonna end screen share. So which means I go here and let's share desktop. All right, so what we're gonna do today is we're going to not do that. That's gonna be part of what we do. I am a little cumbersome with this. Sorry about that, y'all. We're gonna look at nonlinear systems. That's why I have the Desmos there, because you can see what's going on. So the homework's evens only, odds extra credit. So they got 15 problems. And so I guess we'll come back on Thursday and discuss this. So I'm going to give these 3 examples. Okay. Now we had to unfortunately skip the conic sections where we would have been reviewing graphing of circles and what's called ellipses and parabolas that are vertical and or have a horizontal axis of symmetry. Oh well. So the first one, you got a circle with a radius of 4. And what's going to wind up being a parabola, I'm writing it down on the board while y'all are looking at this. Okay, so now I'm going to stop the share. And you can see our first equation. Now, even if you don't visualize this, and again, I'll go to Desmos in a moment once we solve this problem, you can solve this without visualizing it at all. Because this y squared says it's the equivalent of 3x, so we just replace the y squared with 3x. All right, let me just double check. Just double checking participants, just in case one of y'all got bumped out again. All right, so notice we're solving that. So equal to 0, so the 0 product property we can use. We can factor this. Factors of -4 that add to be 3, right? So 4, -1. All right, so now we can factor it like this. And when we solve those equal to 0, we get 2 solutions. And so x is either 1 or -4. Now we got to get the y's. Now, keep in mind here that when we get the y's, if we use this one or if we use this one, we might have a problem. If we use this one, we're going to wind up taking the square root. If we use this one, we're going to square the number first before we take the square root. But either way, if you use the -4, you're going to get 3 times -4. Square root of a negative is not possible. If you use the x squared, you're going to get negative 4 squared, which is 16. If you subtract 16, you get 4 minus 16, negative 12. Again, you're going to still get the square root of a negative. So it doesn't matter which one you use. So we might as well use this one. All right, so we're going to take the square root, which means we're going to do that. Right, so if we use 1, plus or minus 3 times 1, and again, we're going to have the square root of a negative if we use the other one. So this is not possible. So there's two solutions, but it comes from one of the x's. The other is extraneous. It doesn't actually work in the problem, or the system rather. Okay, so we got the solutions are going to be x is 1 and y would be plus or minus root 3. All right, so let's go ahead and look at the Desmos. Let's see, so I guess I share screen. I go here, and you can see the problem here. Okay, so you notice that the parabola is open vertically, right? And that's because over here, we got y equals to the square root of 3x, right? And it's a y squared, not an x squared. And then here's the two places where x is 1. And you can see the two solutions. Those are the square root of 3 and the opposite of the square root of 3. Okay? Oh, wow, it actually tells you who's talking. Interesting. All right, so now I'm going to stop the share, and we're going to do the second problem. Okay. Now, the second problem is a little more involved, and there's two ways you can do this one, but I'm just going to show you one way to make things less complicated, but I'll just say how you could solve these. All right, now, what is this thing? Notice that the two squared terms, x squared and y squared, don't have the same number. So 1 x squared and 2 y squared. That means this is not a circle. This is an ellipse. Now, it saddens me that we were not able to do the rest of chapter 10 stuff, but not a big deal. So this is a ellipse and a line. So we're going to have something like this ellipse thing, and the line's going to cross somewhere at -4 and do that. That may happen. Or that may not happen because this ellipse is over here. So even if you don't visualize this, so you just don't visualize it, not a big deal, because we're just basically going to replace y with x plus 4. And there's two places where we got to replace the y with x plus 4, right there. All right, so notice we're using substitution. All right, so we're going to have x squared minus 4x plus 2. I'm going to put in parentheses x plus 4 exponent of 2. And then we're going to have 6 times x plus 4 minus 5. All right, I'm going to go ahead and erase this little picture over here. Okay, remember we're putting this equal to 0. All right, so it's just a matter of solving that. I'm going to save a little time. So what happens when you multiply all that out is you should get this. All right, and again, what you want to do when you multiply it all out is don't multiply the 2 here, because you got to do the exponent first. So this would become 2 times x squared plus 8x plus 16. And again, remember, it's not distribute the exponent. This is not x squared plus 4 squared. All right, so just to point that out. Okay, so far so good? Okay, now I know you guys know how to do the quadratic formula, right? So A, B, C. Now, when you finish that, you're going to wind up with the square root of a negative. This is going to wind up being negative 288 over, what, 6? That means there's no solutions. Okay, that means we had this situation. Or it could have been over here. All right, I'm going to pause. Again, just shout out anything if you need or if you prefer the text. Okay, I'll assume everybody's okay. I'm going to show you the Desmos picture of this. Okay, so let's see. I guess I share screen. Go over here. And let's see, this would be the trig ellipse plus line, no solution. Okay. Oh, I didn't realize I muted y'all. Oops. I didn't realize I'd unmuted y'all for some reason. Okay, so I just unmuted everybody. Eventually, maybe you mute yourselves. That's all good. So you can see what happened is exactly what I said. All right, so the y-intercept of 4. Okay. Now we're going to go to the hard one. Now, I debated whether I should give this one to you guys or not. It's not on the homework. But let's see. If we ran out of time, I'd do it. But we got time. And y'all want to learn some hard, interesting stuff, right? All right. And this next one is going to be called a non-analytic. All right, I'll point out what that means in a second. And it's a doozy. All right, so we got our x squared plus y squared equals 9. And then we got our xy minus 2y equals x minus 3. Okay, now again, you don't have to visualize this problem to be able to solve it. All right. We're going to have to do substitution. So how do we substitute? Well, we want to substitute into this top equation, probably, because it's a little simpler. All right, which means we either replace x or y. Well, which would be easier? Well, it looks like we can factor out the y here and quickly get y in terms of x. So that's probably going to be the better way to go. So I'm factoring out the y. Now we got a quantity multiplied to y, so we can divide. So what we got here is a rational function. And it has a vertical asymptote at 2, right? And the horizontal asymptote, remember, as x goes to infinity, the ratio of the coefficients, 1 over 1. So this has a vertical asymptote at x equals 2 and a horizontal asymptote at y equals 1. All right, so right there and right there. All right, and notice when x is bigger than 3, this is positive. When x is in between 2 and negative 3, negative up here, positive down here. Okay, and then notice the x-intercept rather, when this equals 0, x is 3, which would be right here. All right, so the same thing, the y-intercept, which would be 3 over 2, so this would be 3 over 2. All right, and so then we got our circle with a radius of 9, centered at the origin. So it looks like we have this. And we already got one solution right there, 3, because this is going to go from 3 to -3 up and down. So that's probably what we're looking at. All right, well, let's go ahead and substitute back up into here. Now this is where it gets tough. Now again, I'm using brackets to make this a little easier to see. I'm gonna go ahead and put this equal to 0, so that's why I'm subtracting 9. All right, we want to use the zero product property. Right now, it's not going to be possible. So what do we do then? Well, let's get a big fraction equal to 0. All right, so if we're going to get a big fraction equal to 0, this is basically x minus 2 squared. So we need to multiply top and bottom by x minus 2 squared. This numerator will be x minus 3 squared. This x squared will be multiplied by x minus 2 squared, top and bottom. And this 9 will be multiplied by x minus 2 squared, top and bottom. All right? Okay, and this is where it gets fun because we're going to have a whole lot of stuff in the numerator. And so again, we're just going to ignore the denominator because if we have a big fraction equal to 0, it's only because of the numerator. So I'm only going to write the numerator expression, and I'm not going to simplify this at all. Okay, so that equals 0. Now, you don't have to multiply this all out because the beauty of the modern world is we got Desmos. Desmos will take this. Now, if you did multiply it all out, what you're going to wind up with is, let me write this over here, x to the 4th minus 4x cubed minus 4x squared plus 30x minus 27. And we want that to equal 0. So we can solve this. You might remember when we used the graphing calculator, right? And we used the table, and we located the zeros, right? And it looks like there's potentially 4 solutions. These 2 and these 2. So this would be a polynomial, and it's to the 4th power, so it probably does something like that, and then those would be the 4 zeros. So that's one way to do that. We could do this too, but I don't know if the graphing calculator would be a good idea to put this in, although it might. I haven't tried it out. So you may not have to go into this polynomial if you're using the TI-84. With Desmos, it doesn't matter. Okay? And so basically we're going to use Desmos to find the solutions of this problem, and we're going to get 4 of them. And then once we get the x's, we can go right back up here and solve for the y's by doing that. Or you could just use Desmos and it'll get you the same thing. So notice if you solve this for y, that's what you could get. So there's another way you can go ahead and get the y's once you get the x's. So depending on how you guys go about this. Okay, anybody want to ask anything or say anything about that? Now again, I'm just showing this to y'all because I think it's important. We've already looked at how to solve these polynomial equals zeros periodically. I think I gave y'all a problem where it was something like that, maximizing area, I think. All right, so I'm gonna wait a minute, and then I'm gonna show you the Desmos. Just ordered a pack of 36 black markers from Amazon, and I don't know if they're gonna show up by the end of the week. So right now I got one black marker left. Not a big deal. Okay, so now I'm gonna go to Desmos and show you how cool this is. All right, so we got, let's see, the trig circle plus rational. Yeah, that's what this one is. All right, now we're gonna open that graph. Okay, now I didn't highlight the two equations first. So if you notice exactly what I drew on the board, we got our two solutions right here. We got this one, which we already knew from the intercept, the x-intercept of the rational function and the radius of the circle, which is 3. And we have this one right here. And then we have this one over here. Right? Well, here is the clunky form of the equation. Now, you might wonder why this x squared minus 9 is. I'll point that out to you later, but it's just because I pulled out the x minus 2 squared term that was both multiplied to x squared and minus 9. And then down here is the polynomial. All right, so let's look and see what the polynomial says. Look at that. Right over those 4 locations. Doompy, 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 doo. All right, as opposed to this one, same exact thing. All right, this is called a non-analytic equation because there's no equation solving techniques we can use. We can do the substitution, but we wind up with this degree 4 polynomial. We can't use a quadratic formula. We can't complete the square. We have to solve that using non-analytic methods, which means estimation methods. And that's basically what Desmos is doing here. It's just highly functional. It's able to do that very quickly. Okay, and let me show you how I created this x squared minus 9 term real quick. Let's see, what am I doing? Hold on now.
Mr. Napoli, we can't see the screen right now.
Yeah, I'm just realizing that.
Oh, okay. Just, yeah.
Okay. Appreciate that. Thank you. I thought I shared it with y'all. I guess I didn't. Yeah, I didn't share that with y'all. Okay, so let me back up and just repeat what I said. Sorry about that. So I should share screen. And that would be that. Let me stop share screen. Appreciate y'all's patience. All right, so this is what I was talking about. So this is the screen y'all couldn't see? All right, so this was the equation I just went over. I'll just repeat what I said earlier since apparently I goofed up, didn't push share screen, boink. Okay, so notice here's the parabola. And it looks like I did something doinky. All right, so let me go ahead and add x squared plus y squared equals 9. All right, so you can see the solutions here. That one, and remember that was the one that had the x-intercept of the rational function and the radius of 3 of the circle, right? And then this one and this one. Okay, so here's the parabola. I'm sorry, I'm calling it parabola, I'm stupid. Here's the polynomial, right? And notice that when that equals 0, we get the same solutions. Doink, 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 doink. Okay, and then this one up here, you might wonder, well, why is that x squared minus 9? That's because I factored out the x minus 2 squared term. I'll show y'all, which is what I was about ready to do until y'all told me, oh, you can't see what I'm talking about. And so notice it's the same thing. So this is called a non-analytic equation, right? Non-analytic equation, because we cannot solve this system, which results in this polynomial, degree 4 polynomial. There's no technique we can use to solve that. We have to use approximation techniques. It's just that Desmos is really good about doing that. And then this is what I meant. So notice these two are the common factors of the x squared and the -9. So that's why I simplified that as, let's squeeze this in, as x squared minus 9, and then x minus 2 squared, and then plus the x minus 3 squared. So that's where that comes from. That's where this came from. Okay? Everybody okay out there? All right, I'll wait around for a minute. You know, you can shout out something if you want, or give me a text. I'll be updating grades definitely by Wednesday, but after I get out of here, I'll jump on it. I'm just basically backed up with half of the work over the last 3 weeks. Is basically all I got. I might have to update a vocab, but anyway. Okay, as far as, well, you guys read my introduction yesterday about what we're going to try to do to handle this. So let's see how this week rolls first. I'm open to ideas anybody has, but as long as you participate, you'll get a C for the rest of the year. There's going to be 2 assessments that I'll put on Google Classroom at some point. Yeah, Tori, just send me pictures of what you do to Gmail. And that's just what I'll do. I just go through Gmail and I mark it in my book. Okay? So I've been doing a Desmos of San Francisco cases. And so I just uploaded the cases today. Since we're here, I'll share you all this and then I'll get out of here. So back to Desmos. So let's see, SF, you can see the ones I'm doing. So here's this one. So we just got 85 more cases today. And you can see this is exponential. And then down here, it's based upon the increases. So you can see that we are not going to peak until right about here, which is around 112 days since February 25th. All right, so 26, 27, 28, 29, that's 4. So 108 days from the beginning of March. That's 3 months, y'all. Of course, this data is, you know, dependent upon the accuracy, and if things cool down, then this peak right here may not happen. But I don't know, it keeps me occupied. Anyway, I'm gonna go ahead and stop this share, and let's see. So yeah, Miley, just shoot me an email with what you want, and I'll be able to send it to you, okay? I already have it. I sent out some stuff yesterday to a couple people who asked, okay? All right, this went out okay, I guess. I don't know. Y'all are a better judge than me. Just wait another minute. Everybody all right? Anybody need anything? Okay, I'm gonna go ahead and get out. I'll leave this on for y'all. Y'all can text each other if you want. Yeah, that's just making sure. You're welcome.